Today we will be going over the ICE2 and ICE3 MQTT configuration settings. For some general information, MQTT, or Message Queuing Telemetry Transport, is an open messaging protocol for data exchange. It is based on a publish-subscribe mechanism, a single broker with many clients. As you can see to the right, you could have an ICE3 IO-Link master publish data to a broker, and then another client in a laptop could subscribe to the same broker and receive that information. MQTT is very lean regarding the data footprint with no metadata and works in networks with low bandwidth, high latency, and poor reliability. The IO-Link master will publish PDI data and can subscribe to PDO data. ISDU parameters can be read and written via MQTT. With the broker connection, you will need a server name or IP address, a port, which is generally 1883 or 8883, define whether it is unencrypted or encrypted, authenticate server, and authenticate client with the username and password and the client certificate. Regarding the IP address and port, you will want a broker IP address, the server port, which the default port is 1883, a client ID, which you can choose a unique name and any text string will do, and a topic base path, and you will want to choose a base topic for each unit. So as I talked about before, first we want to go to the server name /IP and enter a valid IP address. And then we want to go to the server port, and the default should be 1883. And then next we'll look at the client ID and choose a unique name. Any text string will do. And lastly, we will go to topic base path, and we will choose a topic base path for each unit. In this case, it's the ICE3. Then we want to enable the client settings and save. Lastly, we can go to diagnostics and go to MQTT and see that our client is enabled and connected. When setting up the broker connection, as I said before, we will need the server name /IP, the server port, the client ID, and the topic base path. We will also need a username, which is the username for the broker, and a password, which is the password for the broker. In this next section, we will want to look at the username and password portion of the configuration settings. In our case, the username would be Pepperl, and the password would be Fuchs. You will want to save it again, and then we will go back to the diagnostics page. Go back to MQTT, and you can see that it is still connected. Next, we will go over what is TLS. TLS encrypts data to and from the broker, just as HTTPS does on a browser. It allows for server authentication, which is optional, and it allows for client authentication, which is also optional. It needs to be supported by the broker, and it usually uses port 8883. In this next example with the TLS handshake, you can see that the client and the server are communicating with each other. You can see that after the exchange, they both changed the cipher spec, which should encrypt the data. In this next example of a cloud broker with the TLS, we will be using the macchiato.com for the broker. In the following video, we will show the variables being filled. Also note that the network gateway and DNS need to be configured for cloud brokers. This is an example of a cloud broker with TLS. First, we should look at the server name /IP. We will be using the broker Macchiato, so we should put in macchiato.com. And then we will look at the server port, which in our case should be 3883. And then the server authentication certificate, which is provided by the broker. Next, we should check that the username, password, client ID, and topic base path are all filled in. And then we can save it. And then we can go to the diagnostics page, go to MQTT, and as you can see, it should be enabled and connected. For this next section, we will be going over the broker connection with AWS with the server and client. and we will be using AWS IoT for the broker. Some of the variables we will fill in and others will be provided by AWS. Note that in this section, we will not be using the username or password. For this section, we will be showing the AWS IoT for the broker, so that should be going in the server name /IP. For the server port, we will use 8883, which is the default for AWS. The server authentication certificate will be provided by AWS, as you can see. The client certificate will also be provided by AWS, as will the client private key. As I mentioned before, we will not be using the username or password, so we can take that out. However, we should leave the client ID and the topic base path as they are. We can then save our configuration. Another setting for the broker connection is the verify server certificate name. When this setting is true, the server name on the server certificate sent from the server must match the server name /IP field setting. Thank you for watching this video. If you have any questions or comments, feel free to contact us. And don't forget to like, share, and subscribe to our YouTube channel. Stay tuned for our next video and have a great day.